Warmup number 64 is on the screen. Number 1 says write in slope-intercept form and graph. They give us 12 minus 3y equals negative 6x. Number 2 says graph f of x equals x squared plus 1. Number 3 says factor by grouping. They give us part A, x squared plus 5x plus 10 plus 2x. Part B, 6x squared plus 5x plus 1. Bless you. Number 4 says divide the polynomial using synthetic division. We have parentheses 12x cubed minus 19x squared minus 12x plus 4. All that divided by x minus 2. And number 5 says solve the system using substitution. They give us the two equations. The first one is x plus y equals 5. The second one, y equals x plus 3. Give you guys a little bit more time for that. Copy and go. Alright, let's see what we got. Number 1. Being that it's Monday, I'm going to go over this myself. Here it goes. Number 1 says write in slope-intercept form. What does that mean, Mr. Q? Well, we need to solve for y, or leave y by itself. Which means I need to get rid of this 12, positive 12, so I subtract 12 from each side, subtract 12 from each side. I'm left with negative 3y equals negative 6x minus 12. And then at the end, divide by negative 3, both sides. That means we're left with y equals 2x plus 4. That is slope-intercept form because the coefficient of x, which is the 2, is the slope, and the constant, the plus 4, is our what? Our y-intercept. Y-intercept. Okay. Then it says to graph it. Okay, let's graph it. Let me graph it over here. So I have x and I have y. I start with my constant, which is y equals 4. So y equals 4 is about right there. 1, 2, 3, 4. And my slope says to go up 2 and 1 to the right every step. So I go 1, 2, 1 to the right, plot my point, do it again. 1, 2, 1 to the right, plot my point, do it again. 1, 2, 1 to the right, plot my point, and graph my line. There it is. Piece of cake? Yes, Mr. Q. All right, good. All right, next. Number 2. Says graph f of x equals x squared plus 1. That means I need to first graph the parent function, which is f of x equals x squared by itself. So that one, we know it's a quadratic going to the point of origin. So the vertex is at 0, 0. There it is. So that means I need to do some transformations. Look at it. Does it have an h next to the x? No. So it's not going either to the left or to the right. However, do we have a constant? Yes. What is that going to do? It's a positive 1. That means it's going to go up 1 step. So I take the vertex, move it up 1. And now my new parabola is going like that. Number 3, factor by grouping. First it needs to be in standard form. So x squared plus 5x plus 2x plus 10. And you should have grouped GCF and so on and so forth. Yes? So factors are x plus 2, x plus 5. Hands if you got that. Yeah. Next, that times that is 6. Middle, why did I make it to a fraction? Oh, cute. 6. Middle term is 5. So what two numbers multiply give me 6 that when you add them give us 5? 2 and 3. What's my leading coefficient? I'm going to use a shortcut just to go a little bit faster, even though we already know how to group and factor. So I'm going to make this these two into fractions using the 6 as a numerator. So, can I simplify this fraction? Yeah, divide by 2, so that leaves us with what? 3 over 1, so my factor is 3x plus 1. Can I simplify this one? Yeah, divide by 3 top and bottom, so we're left with what? 2 over 1, so that means 2x plus 1. Woo, let's go. Once again, that's the Escalante method, yes? Move on. If we were to put the divisor equal to 0 and solve, our divisor is 2. This is in standard form, nothing is missing, so I'm going to use the coefficients to write my synthetic division, 12, negative 19, negative 12, and 4. To get started, bring down the first term, and then multiply and combine. So this times that goes right there. Combine, that's 5. 2 times 5 goes there. Combine, that's negative 2. 2 times that is negative 4. Combine, that's 0 left over. So that means if we started with an x cubed, this is an x squared. That means this is 5x. That means this is minus 2. I'll stop right there. That could be factored, I think, a little bit more, but I'm going to stop right there just for the sake of time. Last but not least, solve the system using substitution. I'm giving you plenty of practice. We started already last week. We've done this from the beginning of the school year, but I'm bringing them back because hopefully by the end of the week we'll get to systems but with 3 variables and 3 equations, and it's going to be like riding a bike on fire, right? There we go. This one's already solved for y. What is y? This. Which means we can substitute the value of y right here. Instead of writing y, what do we write? X plus 3. So I would write x plus, and instead of y, I would write x plus 3. Combine stuff. This is 2x plus 3 equals 5. Minus 3. 2x equals 2. Divide by 2, x equals 1. So my solution for this one in parentheses starts with x equals 1. So now that all we need is a y, yes? So I'm going to substitute here for the second equation 1 for x. So what is y? Y equals 4. This is my solution. But what does that mean? Talk it over your neighbor. What does this point mean? The solution to that system. Talk it over your neighbor. What does that mean? Yes, that's where both lines are going to intersect if I was to graph them. Yes? All right, set that aside. Let's go to our agenda for today. Here we go. Our agenda for today, we got warm-up number 64. We're still working on parabolas, and today you only have 6 itty-bitty ones, graphs of parabolas. You're like, why so little, Mr. Q? Well, because you're going to see today. Woo! Let's go! What am I talking about? You guys did your home play over the weekend. You're plenty of practice. You got it done. So, it should be automatic, everything we're going to do today. Let's go. So, yeah, guys, second semester, you cannot not do your practice. Please do your practice. Please, pretty please. With a cherry on top. Please, please, please. Yes. All right. No asynchronous code. Your weekend home play were these 4. You guys did that practice, yes? Good. Show your neighbor what you did, and then take a picture of today's home play on the screen. Okay, we good? All right, and the weekend home play was just for you to practice. I'm not going to pick that up. Right? You're like, Mr. Q, I already copied it from someone. Well, hold on to it. All right, let's move on. All right, get a Cornell note, and could I get, let's see, the last person on each row will get a graph paper for your row. Here we go, our objective for today. I can write and graph a quadratic equation of parabola. I can write and graph a quadratic equation of a parabola. Today we don't need a Fourier model since we already started with this session since last week. We've been adding a couple of steps here and there, and it's kind of like snowballing till today. Today's going to be a good session. It's a little challenging because it's a multi-step section, but we got it. So, what are we doing today? We're writing and graphing quadratic equations in standard form of a parabola. Okay? Got the objective? So this is what I want us to do today. Today I want the work to be done on your Cornell note. And the graph only on the graph. Okay? Except for the first column that we're going to do a review of what we did last week. That one is, the whole thing's going to go on the big graph. But anything else is going to be graphed by itself. Alright, there we go. So last week we said that parabolas, I gave you guys the Fourier model, were the set of all points equidistant from a line known as the directrix and the focus. Here they are. This curve is a parabola. And then I asked the question, alright, what point is the immediate point between the focus and the directrix? The vertex. The vertex is right there. That's usually the 3 points that we use, the focus, the vertex, and a point on the directrix. Yes? So far so good? Sound familiar? Yes, Mr. Q. Alright. So, from there, I gave you guys a standard form equation, which was that one. Yes, and then from there, I left you guys some home play over the Christmas break. You needed to memorize this process of how to derive the quadratic equation. Yes? Yeah. Oh, yeah. I remember that one, Mr. Q. Okay, good. Got with your family together. Gather around, folks. Here you go. From there, we did, and we agreed we're going to be looking at two types of parabolas, vertical and horizontal. Now, look up to the screen, please. I'm going to try and get your noodle ready, because where we're headed, you need to start thinking it out. Here it goes. Vertical parabola, which one has the squared? Which variable? The x. You guys notice that? Hopefully you also notice that the x is on one side of the equation and the y is on the other side of the equation. However, for a vertical parabola, when the x has a squared, notice that here's my parabola. There should be a focus right here. There should be a vertex right there and a point on the directrix. So what do all three of them have in common? The x value. All of them have the same x value when the x has the square. Let me repeat that again. For a vertical parabola, all 3 points, the focus, vertex, and directrix have the same what? X value when the x squared, when the x has a square. Therefore, horizontal parabola, when the y has a square, the focus, the vertex, and the directrix have what in common? The y value. All of them have the same y value. Trying to get you there. I'm telling you, you're going to need to think this out. From there, we did some practice, and we went and did a couple of these. Boom, boom. And then I said, let's crank it up a notch. We introduced h and k. There they are. That's what we did last week. That's what you did over the weekend by yourself, right? And then from there, we did some practice on those. So just for the sake of those that were absent, right? Welcome back, Pamela. Yeah? Let's do another one, yeah? Get your big graph in front of you. Copy this one. Example 2, Star Wars cube. On the graph paper, the big graph paper, don't copy the instructions. Just copy the focus 5, 6, and directrix y equals -2. I'm sorry, y equals 2. All right, here we go. We're going to do this one together, and it's going to go pretty fast since we already know how to do these, yes? Here we go. So by looking at the directrix, look at it. What equation in standard form are we going to use if the directrix is y? Share with your neighbor, what equation are we going to use when your directrix is y? Alright, so on the side of your graph, halfway down, I want you to write, yes, x minus what? H squared equals 4p and y minus k. You guys remember this, yes? Yeah. And then I said, let's change the h to green and k to green, so like that we know that that's going to be our vertex. Remember, our vertex is h, comma, k. All right, let's get organized. We start off by writing all three. The focus, vertex in green, and directrix in blue. And also we need the distance between all 3 points, so we write P. I gave you guys a little formula that we need to subtract 2 values, divide by 2, because there's 2 distances from here to here, from here to here. And that's going to give us P, which is the distance. What do we do from there? Let's see if you remember from the weekend. We graph our focus, plot our focus. What is 5, 6? Let's plot our 5, 6 is right there. So that goes right there. What's our directrix? Y equals 2. Y equals 2 is right here. And there's a line, straight line going through there in blue. There it is. But we need a point. We can't use that one because it's not aligned to the focus. So we look at the focus, go straight down to the directrix and plot your point. And what is the coordinate for that one? 5, 2. So we write it here, 5, 2. So, since the x has a square, what do all 3 points have in common? The 5, yes, the x value. And all we need to find here is k. How do we find k? Well, we take the y value of the focus and subtract the distance between the points, or p. So by looking at it, look at the graph. How many points do we have right now? 2. So we need to subtract 2 values. Can I subtract the 5? No, because I'm going to end up with 0, and it's not 0 distance. So which are we going to subtract? The 6 from the 2. So 6 minus 2. What is 6 minus 2? 4. What is 4 divided by 2? 2. So the distance between each of the 3 points has to be 2. Which means to find this value, I need to substitute 2 right here. And the y value of the focus, which is 6, goes right there. And that's how we find our k. What is k? K is 4. Plot 5, 4 and see if it's equidistant. 5, 4. Is it the same distance from each of the points? Yes. Is it 2 steps away from each point? Yeah, because that's what we got here, too. Can we graph our parabola? Yes. Now look up. Does it go like this? Tell your neighbor, why not? Yeah, it has to go away from the directrix. It always goes away from the my goodness. Let's see. There it is. Woo, let's go. And arrows at the end. Are we done? No, Mr. Q, we're done with the graph. Now we just need to write our equation. Okay, so I write x minus blank squared equals 4 parentheses for p, y minus blank for k. Now, tell your neighbor what h and k are. What values do I substitute in there? Yeah, from the vertex, what is h? 5. And what is k? 4. What is p, by the way? 2. That goes right there, and then we just simplify. X minus 5 squared equals 8, y minus 4. This is our standard form equation of a quadratic of a parabola. Right? Plenty of practice for that? You guys did that on your own over the weekend, yes? Okay, good. Because today, we need to come up with this equation. Look up with this one. We need to graph it using these 3 points. But the trick is that I'm not going to give you an equation that looks like this, and I'm not going to give you the 3 points. So what are you going to give us, Mr. Hugh? Copy this on your Cornell notes. Here we go. Example 3. Example 3 says, write and graph the equation of parabola in standard form. Equation given, x squared minus 4x minus 4y plus 12 equal to 0. Copy that. I'll give you some time. Copy and go. So, we're going to do all the work on your Cornell notes, and at the end, we're going to graph it on your coordinate plane, on the little ones in the back. Yes? Make sure you label each one independently. Okay? However, before we get started with this, let me go back to the previous problem. Look up. Look up to the screen. So, to get our brain ready, which one has the square? The x. Notice that the x is on itself on one side of the equation. So what do we have on the other side? The y is on the other side. What would all 3 points have in common? The x, because the x has all the square. How about for the horizontal? We have the y squared on one side and the x on the other side. So what all 3 points would they have in common? The y would have in common because it has y squared. Okay? So for today, we need to make this one look like one of the other equations. So writing utensils down, here goes the process. Ready? I'll have you copy along the way, but writing utensils down, just pay attention. Look up. To get started, I need to make this one look like what we've been working with. Well, first I need to picture the equation before I start moving that one around. Which variable has a square? The x. That means the equation that I need it to look like has to have the x with a square. Is that correct? Which means on the other side we should have what? 4p and what? Y minus k. This has to look like this. And right now you're just paying attention. I'll have you copying it. Relax. Here it goes. So that you see that I'm going to leave one side independent from the other. I'm going to draw a dotted line down the equal sign. And what do you notice on this one? That both the y and the x are on the same side. We need to leave x by itself. Is that correct? All right. So look at it. So leave x by itself. What do I need to do here? Add 4y and subtract 12. Add 4y, subtract 12. Do that with me, please. This cancels. We're left with x squared minus 4x, empty space, equals to 4y minus 12. Notice what I said, empty space. I want to trigger your noodle because we've done this process before. All right. So, Mr. Q, why did you say empty space? Because we need to complete the square. So how do I complete the square right here? Who remembers? What do I do? Carlos. To both sides, yes. Negative 4 divided by 2 to both sides. Negative 4 divided by 2 to both sides. So let's rewrite this. X squared minus 4x plus negative 4 divided by 2 is negative 2 squared. That's positive 4 equals to 4y minus 12 plus 4. Can I combine stuff on the right side? Yeah, the negative 12 and 4, that gives me negative 8. 4y equals x squared minus 4x plus 4. All right. So far we said, we looked at the equation, we saw that the variable that had the square was x, so that's why we wrote our standard form to look like this. That means we needed to make this one look like this. That means we needed to leave x by itself. That's why we got rid of the y and the constant. There it is. And then we completed the square for the empty space to both sides, and we're here. Writing utensils down, look up to the screen. Here we go. I want you to think this out. Ready? Here it goes. Next, according to the completing the square process, we need to factor next. Okay, don't write this down, just pay attention. I'll have you copy in a little bit. So, how do I factor this one in completing the square? You guys remember? Yeah, square root of the first, square root of the last, sine of the middle, square. Can I do that to this? No, but what's another way of factoring? It's called what? GCF. What's GCF for these two? 4, and we're left with y minus 2. Now check this out. Is this our standard form equation? Let's find out. Does that look like that? Yes. Copy that, please. All right, so the first part is done. We already rewrote this equation in standard form. Here it is in red. This is our standard form equation to the parabola. But now what do we need, Mr. Q? We need to graph this, which means we need 3 things, don't we? We need a focus, we need a vertex, we need a directrix point, and we need P, which is the distance between all 3 points. Okay, so by looking at our equation, this one, the one we came up with, what is our vertex? Everyone. 2, 2, that is correct. 2, 2. If you don't see it, here it is. H is 2 and K is 2. There it is. Since the x has the squared, that means that all 3 points have what in common? The x value, right? So this one is 2, and this one is 2 of x. So what is the only thing that we need to find? The distance between each of the points. Well, check this out. Look up to the screen. If I have this, but this is the original one, that means I can use that information to create an equation, which is 4 equals 4p. And to solve for p, I divide by 4, so 1 equals p. So what does that mean, Mr. Q? That each point has how many steps away from each other? 1. Now check this out. But we're going to use some algebra. Here we go. So from the vertex upward to the focus, it's 1 step. Is that correct? Or in other words, I can say k, which is this one, plus p. Yes? Because it goes up 1 point. If that's true, how do we find this value? K, what else? Minus p. That is correct. Let's see if it works. This is 2 plus p, which is what? 1. What is 2 plus 1? 3. Yes? How about this one? Again, 2 minus, what was p? 1. So what is 2 minus 1? 1. All right, let's plot those points. 2, 3. 2, 2 for the vertex. And 2, 1 for the directrix. And there should be a line going straight through the directrix point. There it is. All right. And can you picture our parabola already graphed? Yes, Mr. Q, there it is. Ooh, let's go. Good thing you guys did your practice over the weekend, right? Let's go. Let's go. And I don't know if you guys noticed, we went actually backwards. We did the process backwards. That's why we do plenty of practice like that. You know it frontward and backwards. Does that make sense? Yeah? So here goes the process one more time. I gave you guys an equation, and the first thing that we needed to check which variable has a square. This one had the x, that's why we were able to write this as our standard form. From there, we needed to leave x by itself, which is the x squared and the negative 4x, and then we brought everything else to the other side. From there, we completed the square to both sides, factored both sides, and we end up with our standard form equation in red right here. And we wrote it underneath. To graph, we needed the focus, vertex, directrix, and the distance between the points, which is p. We said that the vertex, we can get it from here. X, the h, and the k, which is right there. And since the x squared, the x has a square, that means all 3 points have the x value the same. To find the distances here, we just needed to use this as an equation to solve for p, then k plus p and k minus p. From 1 to 5, how comfortable you feel with those? Got some 3s, 4s, 5s, okay. All right, let's do another one. Yes, here we go. Example 3 mega cube. X squared plus 8x minus 16y minus 448 equals 0. Question. Which variable has the square? X. So tell your neighbor what you're going to write next to it as your standard form. What do I write, everyone? Yeah. X minus h plus 4py minus k. So, line down the equal sign, line down the equal sign. I need to leave all x's to one side. Tell your neighbor what to do at that step. Andy, go. Add 16y and add 48. Add 16y, add 48 to both sides. We got x squared plus 8x, empty space, equals to 16y plus 48. Complete the square. Tell your neighbor what to write there to complete the square. Tell your neighbor what to write right there. All right, Brooke, what do we write? Close. Positive 8. 2 to the power 2, yes. 8 over 2 squared. Okay, let's simplify that. X squared plus 8x plus 16 equals to 16y plus 48 plus 16. Can I combine the right side? Yes, that's 64 and 16y. This side is x squared plus 8x plus 16. Let's factor. 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 Okay? How do we factor? Shortcut. What do I do? Square root of the first, yes. Square root of the last, 4. Sine of the middle, squared. This one, we can't use that method, but we can find what? GCF. What's our GCF? 16, and we're left with y plus 4. So does that look like our standard form? Let me check. X minus squared 4py minus, this is h, and this is k. Yes, that does look like it. All right, so let's graph. What do we need to graph? 3 points. The focus, the vertex, the directrix point, and we need the value between the points, or the distance between the points, which is p. So, look at it. Tell your neighbor the vertex, please. What's the vertex according to the equation that we just got? Vertex. Be careful, because it's got a little curveball before you just write it out. What is our vertex? Good communication. Nur. Vertex. -4, -4. Damn, no hesitation. -4, -4. Yeah, because this is supposed to be a negative, right? This one and this one right there. So, because it's part of the form. Negative and the negative. So, be careful. All right, so which had the squared, the x, right? That means that all 3 points have what in common? The x value. That means the x value here is -4, and the x value here is -4. Look at it. How do we find p? Talk to your neighbor. How do we find p? How do we find p? Yeah, make an equation. I heard 16 equals 4p. Yes, and solve for p. Divide by 4, divide by 4. Therefore, 4 equals p. So, how do we fill this? K, that means this one is, since it's above, it's plus p, and this one is minus p. So, what was k? K is -4, -4. This one is plus p. What is p? 4. What is -4 and 4? 0. Yes. This one, -4 minus, what is p? 4. What is -4 and -4? That's -8. So, -4, -8. -4, -4. -4, 0. Our directrix going through this point right there. And can you picture the parabola? Oh yes, Mr. Q. Woo! Let's go! Let's go. I mean, not yet. We're almost done. All right, from 1 to 5, how comfortable are you with that so far? 5 4s, yeah, a lot better, yeah. 5 4s, 5 4s, yeah. Once again, reminder, please, pretty please do your home play. My goodness, it's going to continue building up. All right, so far so good? Let's do another one. Here it goes. Example 3Q, copy this. Y squared plus 4x plus 8y plus 4 equal to 0. On your Cornell notes. Again, we need to write our equation and then graph it at the end. All right, look at it. Question, which variable has the square? So, with that said, write your standard form equation over here on the side. See if you get it correct. All right, which was what? Y minus k squared equals 4p x minus h. So line down the equal sign, line down the equal sign. So what do we need to leave by itself on the left side? The y, is that correct? All right, so that means I need to leave the y squared and the 8y by itself. So what do I do here to get rid of the rest? Raymond? Minus 4x. Minus 4 to each side. Minus 4x minus 4 to each side. This cancels that. Bless you. We're left with y squared plus 8y. empty space equals negative 4x minus 4. Complete the square. How do we complete the square? Bless you. Andrew.
8 over 2 squared.
8 over 2 squared to both sides. 8 over 2 squared. So that leaves us with y squared plus 8y plus 16 equals 2. Negative 4x minus 4 plus 16. Can I come on the right side? Yes. This is negative 4x plus 12. Bring down the rest. Y squared plus 8y plus 16. I need to factor at that point, yes? Factor. Factor. Do we know the shortcut? Yes? Yes, Mr. Q. Square root of the first. Square root of the last. Sine of the middle. Square. How about this one? What's GCF? Negative 4. We're left with x minus 3. Is that our standard form? Let's check. Y minus squared 4p x minus something squared. Let's see. This is k and this is h. Does that look like that? Yeah. Let's graph. Focus, vertex, directrix, and the distance between the points p. All right, be careful with this one. Here goes the question. What's our vertex? Don't get mad. What's our vertex? Oh.
Negative 4 and 3.
Close, very close. Yeah, 3 and negative 4. Yeah, be careful. Notice that the h is over here now. Yes? Okay. Which variable has the square? The y, which means all 3 points are going to have what in common? The y. So this is negative 4 right there, and this one is negative 4 right there. So now we need to know the distance between the points. How do we do that? Make it an equation, yeah? So we would write negative 4 equals 4p, divide by 4. So my distance or between the points is negative p. So now look, wait a minute, Mr. Q, but now we have to figure out x, not y. That means I'm not going to use k. What am I going to use? H for both. This one is plus p, and this one minus p. So what is h? 3 plus p, which is what? Negative 1. So what is 3 minus 1? 2. And this one, 3 minus negative 1. What is negative times a negative? Positive, so that is positive 4. Plot those and see if they are equidistant. 2, negative 4. 3, negative 4. 4, negative 4. With a directrix going through that last point. And our parabola going through the vertex, opening away from the directrix, and there you go. Woo! Let's go! Do we have time for one more? Yeah, I think so, right? Show me what you're how comfortable are you with these so far? Yeah, 5, 4, 12. It's just a process, right? Just a process that you need to follow. Guys, I'm telling you, please do your home play. Last Friday we did a block party, but this Friday we're doing a let's go. Yeah, we're going to try and finish up the module before the end of the week. All right, guys, and those of you on video, make sure if you're falling behind, log in at 1:30 every day on Zoom. Go to Canvas, click on the Zoom button, and join us live every day. All right? Peace.